Hey, boys and girls, welcome to Munro Live. And today, what we're going to do is we're going to comment a little bit on what I think is an excellent video that come out from Lucid. It's not often that you'll get somebody like Peter Rowlands taking the time to explain things that are kind of basic engineering philosophies and physics and stuff like that. I thought, I haven't watched the whole thing. I'm going to be watching it for first impressions here, but I saw the first little bit and I was very, very impressed by the way that he explained everything. So Cory and I are going to be going through the video, and we're going to be talking a little bit about sometimes accepting what Peter has to say, but also showing you some examples of how things have happened over the years and in different products. And today what we're going to talk about is VW ID4, the Ford Fusion,
Chevy
Bolt. Everybody's got good ideas, and what we really want to do is this platform, our platform, is to try and educate and to improve, and that's what the whole thing with Munro is all about. So before we get into it, one thing I would like to do is say that Peter did a great job on discussing, what's a watt and what's a joule and things like that. But one thing he didn't do was he didn't mention the name James Watt, which I think is kind of important. James Watt was a self-taught scientist, engineer, whatever, from Scotland. He basically invented the Industrial Revolution because he's the guy that invented the steam engine. He was also very, very interested in how to measure and calculate work done and things like that. So the term horsepower is his, watt obviously is his. A lot of his basic premises on how things work are on the grandest of possible scales. He truly was a first principle thinker, and it's just every once in a while it's a good idea to know a little bit about the background of the guy who basically invented pretty much all of the techniques and technologies that we use now in the way of calculating work done or power or energy and things like that. So yeah. I was pretty impressed though with Peter's presentation. A guy of that stature, I mean, that's amazing.
Yeah, and real quick on the video itself, the production quality was phenomenal. And sitting here with our team, producing this video, they must have spent an incredible amount of time and money in setting this up, the shots, the views. It kind of reminds me of three of our favorite YouTubers. So Jerry Rig Everything does a lot of stuff on a white table, so I love the white table there. Engineering Explain is a whiteboard guy. And then a little bit of imitation of Munro Live. So typically, we would be showing our teardown vehicles, the batteries, the packs themselves. So when this came out, a lot of our viewers are like, are you going to get a Lucid? Are you going to tear it down? Well, I think there's only been 250 made. We don't have one. Yeah. And now if they're going to do this series of tech talks, it really saves us about $300,000 or $400,000.
Way more than that. and we don't really have too many of our customers that are interested in the Lucid data, mainly because the car is so astronomically expensive and in such a niche that we would have a hard time selling this to our normal Far Eastern or even European customers. So I think that Peter beat us to the punch, and I'm happy for it because really and truly, tearing apart a car that's that expensive and whatnot, that would just be a terrible.
It almost breaks my heart every time I walk by the Plaid, seeing it completely destroyed, knowing how much fun it was to drive that car.
Yeah, actually, I have looked at the Lucid, but I wasn't allowed to drive it. It looks really nice. I'm not sure if it's quite the same category as a Bentley or a Rolls Royce or a Maybach or something like that. But still, in all, it's going to have a market, a limited market, but still, it's going to have a market. And what I saw was really well done. The gaps were perfect, things like that. I think that it'll do really, really well. But having this this little pitch that Peter put on, I think it's going to probably help sales, and and it definitely is educating those people who are maybe not quite engineers, and showing, in essence, how everything works. I like it. I like it a lot.
In the interest of time, we are going to start watching this, but we may skip ahead to different areas that are of interest to us. This is a 36-minute video. I highly recommend checking it out after you watch our video here. Like Sandy mentioned earlier, I had already watched this, so I grabbed different pieces and parts to compare and contrast other OEM strategies when he's talking about Lucid strategies. So we're going to go ahead and kick this off. We're going to start play. Sandy and I are going to watch, and let's go.
Great.
All right, so right here, Peter is going through the watt hours needed to drive per mile. So when Sandy and I took our long road trips, oftentimes we were driving fast, up mountains, cold temperatures. We were in the 300 to 380 watt hour per mile scenario in the Model 3 and the Model Y. But when we hit warmer temperatures, flat ground, driving through Texas and whatnot.
Yeah, going downhill.
Yeah, we saw it in the mid to low 200s. So Peter's talking about 250 watt hours per mile as being, that is essentially the goal right now for efficiency. Now that's efficiency of the whole vehicle, not the battery pack. So he may just be he's talking about the battery packs right now, but it's the total system, the aerodynamics, the rolling resistance, your motor technology. And that's why you see pretty much the biggest battery packs in sedans are about 80, 90, 100, or 110 kilowatt hours.
Right.
Yeah.
Or in the case of Tesla Model 3,
75.
Yeah. So the size of the battery is just one factor that has to be taken into account. But the efficiency of the electric motors, the friction coefficients that you can get rid of an aero, and weight, of course, as well. Because as you add batteries, you're adding weight, which reduces your capability for watt hours per mile.
Yeah, and MPGE is really that number that we like to focus on. So look at the Hummer, recently announced with a 200 plus kilowatt hour battery, but it only gets 42 to 47 MPGE.
Yeah. So
you're carrying the battery's weight as a crutch to get the range that's acceptable. Yeah. But if you're looking at the gasoline or diesel that you would have to carry in a large SUV, you'd be looking at a 25 to 28 gallon tank versus a 17 gallon tank from a small sedan to a large SUV. So the difference in weight that you need to carry for a large SUV is astronomical. That's why the Hummer's battery weighs 3,000 pounds.
Well, at the end of the day, that battery pack weighs 3,000 pounds, but the Hummer itself is 9,000 pounds of rolling action. To me, that eclipses pretty much everything. Nobody has anything quite that heavy and quite that ineffective or inefficient as far as a battery pack to actually miles that you can actually travel. So,
all right,
there's no point in beating that horse. Let's continue on.
So Sandy, they just gave a quick overview of what their EDM, electric drive module, looks like. I still see a rather large, bulky, rectangular inverter.
Yeah, so do I. And I don't know how they compared themselves to everyone else. But to me, just at first glance, that did not look like the compact. I mean, really and truly, from what I could tell, the only guys that have got a really compact drive system is the one that we saw on the Ford front and the Tesla models.
Yeah, the Ford front was a relatively low output unit.
Yeah.
This is a very high output vehicle. So I think even their slowest vehicles have 500 or 600 horsepower.
Yeah.
I did notice that, you know, in that cutaway, maybe we'll stop the video right at the perfect spot. The differential looked like it was in the center of the drive unit.
Yeah.
So there, it doesn't look like they're using an offset. So when people say the most compact or the most efficient, is it gravimetric or volumetric? Is it based on weight? Is it based on volume? Sometimes I'm more worried about cost and scalability. So in a recent video, Sandy, you showed the inverter from the Model S Plaid. The rear unit is the same form factor, shape, style as the Model 3 and the Model Y and the Model X. It'd be interesting to see here if they have that same level of cross-platform scalability.
Yeah.
Yeah.
Okay, so Cory mentioned gravimetric or volumetric, and this is the most volumetric efficient powertrain that's out there. So again, I'm looking. I see a great big giant box for the inverter, but what am I looking? Yeah.
So there's the rotor.
Yeah.
You can see the stator right there.
Yeah.
And it looks like the center of the rotor is actually pretty wide, and it has gearing inside of it. So each output left and right is driven off of the center of the gearing units. We're at 915. I'm going to hit. See that?
Oh, I also see. Yeah.
There's the spider gears. They're right in the center of the rotor.
Hmm.
Yeah, that is a ultra compact. But what's the first thing I see on here that I still can't believe is on any EV? Park Paul locating ring.
Yikes.
Come on.
Well,
So yeah, right now Peter is walking through why he put one of the modules in the tunnel. But the first thing Sandy and I notice is look at these long orange bus bars.
That is not what I was expecting or hoping to see. I saw them there, and I didn't really, sometimes you ignore things that you don't want to see, and I didn't really notice it until he actually pointed it out. That tunnel area between the seats is kind of a big deal, and that is a tremendous amount of orange. So I'm a little bit surprised there.
So using 2170 cells and having 300 cell modules, I think there's 22 in this vehicle. I think we'll get to that later. The big disadvantage there is you have to connect them all together. And Sandy, what have you been preaching for your whole career?
Yeah, I'm big on limiting the number of parts, and I know where Cory is going to go with this, and now I understand why the battery module is here. So you might as well just dive right in. At 22, or did you say 22 modules?
22 modules.
Yeah, so Tesla has 4.
So when you increase the size of your modules, and the biggest module you can have is 1, if all of your battery cells make up 1 pack, cell to pack. In the Model 3 and the Model Y, they have 4. They have one of these boards on each of those modules. And the reason I'm pointing it out is it's relatively small. And you can see these little spots right here. This is from the Model 3. This is mounted directly to the pack itself, or the module itself. And then all of the monitoring wires right here for either voltage or temperature run along these little connections here. Although they may integrate their battery management boards into their modules, there's 22 of them on each vehicle. 22, and they all have to be connected together. They all have to talk to each other. And where are they in the car, Sandy?
Yeah.
All over.
All over the place.
So there will be low voltage wiring running, daisy chaining them together. They may not show it in this video, but the push to get cell to pack, essentially eliminating all modules, is a huge cost reducer by eliminating the number of boards needed.
Yeah.
And that's why we have this out here. And also your bus bar strategy. In this photo, we can see long, drawn-out, orange-coated bus bars. The VW ID4, they have a great design, a spine design.
Yeah.
Sandy, you wanted to describe?
Yeah. So instead of having, you'll see these bus bars all over the place. Instead of having something like that, what the folks at Volkswagen did was they had two distinct rows of battery modules, and in the center there was a trough, and that trough was connected, or in that trough they connected each one of the different modules via this little dinky tiny bus bar. And okay, so I had some things that I didn't like about the ID4, but I had nothing but praise for this. I think that of all of the different systems that I've seen, that center bus bar idea, or the central spine idea for power, was probably the best thing that they had going, and I don't see anybody that's got anything better than that. So I'm pretty excited about this. You have seen this before. You're all ready for everything, but that doesn't really get me all gooey. So I'm
Yeah.
I'd like to have a deep look at that one.
Yeah. Now, at some point in this video, Peter mentions eagle-eyed viewers. Well, at Munro, we've already sent this video around to everybody, and we're peering very, very closely at these minute intricacies, because it really gets us a window into how the battery pack is truly finally assembled. Yeah, so he's talking about the orientation of the cells. So Tesla cells are also upside down. We have a few here.
Yeah.
And the orientation.
They're cooled on the
sides.
This one's cooled on the top, or the bottom. So they're basically upside down, which, I mean, heat rises, and you've already got the bottom. Usually it's called the battery bottom. We've already got the battery bottom getting warm, so it makes sense to put the cooling plate underneath the floor.
Having already watched this, he goes into great detail about their decision for cooling. So let's actually fast forward to that. We're kind of eking along here.
Okay, so that is something that I really like. I like the way they've put the electronics to the bottom, or the electrical connections to the bottom, and in putting the cooling plate on top. And I see you've got something from the bolt. And so this is a good example of a good idea. I like this on the bolt. They did a good job. So like I said, everybody's got a good idea somewhere. And this was something that was good from General Motors.
Now on the bolt, this is one small portion for an area of cells that isn't on the main pack. There is a massive panel that is used for the plate cooler underneath the majority of the cells. And once again, I know we're harping on modules versus one large pack. They have one cooling plate per module, 22 modules. I think the Bolt had 2 cooling plates, this one and a large one. VW ID4, another one, maybe we can get this photo, the part was too big to bring in. Yeah. They integrated the cooling plate into the lower structure of the pack. Right. It was a second layer, essentially bonded or welded or brazed to the pack. That same design was the genesis for the Sabic concept that we helped them a little bit on. And one thing that's oftentimes overlooked is when you have these cooling plates and you're interfacing with cells, whether they're prismatic, pouch style, or cylindrical, you have to get a really good bond. And what I have sitting on here, Sandy grabbed this is a small portion of the thermal paste. Oh my gosh. From the VW ID4. So it was I wouldn't say thin layer.
Well, it was rolled out like a pancake or something, and then
about that thin, right here.
Yeah, it was about 3 millimeters, I think, something like that. I remember somebody measured it for me. But at the end of the day, that's what you kind of like need to wick away the heat, or to send the heat into the battery, because in the wintertime you need to get it warm, and
with 2 metal surfaces, if this is off even a fraction of a degree. You're only touching a small portion of it. And the same thing with a large square rectangular pack or a module or cell. This ensures that the heat is being transferred across all the surface area, but it adds a tremendous amount of weight to the vehicle. And that's not even all of the VW ID4 paste. Further, let's skip along in the video.
One thing that I would like to do is pose this question. So they're using an extensive amount of aluminum here. When we came up with the new Sabic idea to go with StayMax FR, it would seem to me that isn't Lucid isn't that a huge investor in Lucid, Sabic? I believe they are. I wonder why Sabic didn't get a chance to do something like that here.
Look at the rest of the structure of the pack, of the module, is some sort of plastic. Yeah, let's skip ahead to where Peter goes through the contact patch of the cell. So here Peter is using the flashlight example to show cells in series.
And that's the easiest way to do it, and I kind of did that a long time ago when we did the Tesla 4680 battery show. Anyway, but we obviously didn't invent this. This is from the Fusion, the Ford Fusion, and this is the way it was done at one time. And these came in dual packs. There was two right next to each other, and they had this monster plastic injection molding thing that would snap two of them together. So what he's doing right now is basically saying, okay, here's my series. And then what Ford did was they had the second pack, so they would go series in parallel so that you could multiply up the voltage.
And then they even had multiple sets of two that were even further put in parallel. But when he was showing this example, you know, here at Munro, we keep some of our oldest benchmarking batteries, and
that's old. That's from
this is the Ford Fusion Hybrid, 2010 or 11. I think this was for the Cafe Standard study that we worked on. We can publicly,
that's single digit.
Yeah, and this is literally the cells snapped together exactly like he's showing in the video. The form factor is also rather large. I wonder what this is. What do you think? A 46?
Looks like a D cell to me.
D-cell.
This looks like I don't know what that is, but Ford didn't go down that path for very long. Actually, they kind of moved away from electric vehicles pretty much completely. But that's definitely not a 4680. It's wrong diameter. It would be almost half again as big. It looks to me like a D cell. Long time ago, though.
Yeah, so just for our viewers, we are kind of skipping ahead. We're watching the whole thing, and we're just commenting on things that we think are most relevant. So let's hit play again. So right now he's talking about the contact patch for side cooling, and we recently just chiseled out 3 cells from our Model 3 or Model Y pack. They're both the same. And if you come in here, you can see that he is correct. The contact patches for this thermal, it's like a glue, it's a thermal conductive glue. It varies just slightly. And here is a little sample of that cooling channel. And if you take one of these cells, you can see how it mates real nicely right there. It is only on one side, so they run this channel down the center of 2 cells, and there's a small insulator between the other set of 2. They're not cooling on both sides. It is one side, but if we measured this exact area, it looks like it is a larger surface area than the bottom. But what Peter was talking about here is that the batteries do cool better on the end. And Sandy, you're actually a fan of end cooling.
I am. I prefer end cooling to side cooling. One of the reasons is because these micro channels, and so you might want to zoom in here a bit. These micro channels are a good idea for side cooling. The problem is that they're easily clogged. If there's any kind of debris or anything that could get into these channels, you're going to have an issue. And I know BMW had some problems when they brought the BMW i3 out. They used something very similar to this, and then ultimately they walked away from it and went to a fairly large cooling plate. Personally, I have a lot of good things to say about Tesla, but this wouldn't be my first choice for cooling the battery. So I prefer the ideas that are coming out. Rivian uses the bottom cooling, Lucid obviously, and many others are VW as well, pulling it.
Yeah. Early EVs, the big advantage to side cooling was a reduced height in the Z direction, because they wanted these sedans, which had very limited underbody space, to feel exactly like an internal combustion engine vehicle. And some of the form factors of cells, prismatic and pouch, were so tall, with cooling then stacked in the Z height, that you ended up with an unusual feeling when you got in the car, because the position of the seat, the position of your feet were much higher than it should have been for the vehicle. So the original Model S's and X's were side cooled, but it was an S pattern through the modules. In the larger 4-module Model 3 and Model Y packs, these channels flow linear from one end to the other. The coolant flows in the front of the pack and out the back and back up front. And earlier on, we were talking about the need to flow that coolant from one module to the other. When you have less modules, you have less connections. Sandy, you want to talk about the
connections are so whether it's in this case fluid, hydraulic, whatever you want to call it, or if it's connections that happen to be electric or electronic connections, the more connections you've got, the more likelihood you're going to have a problem. Connections are the bane of, they're the leak path. They're the most likely leak path. They're the most likely to fail in the field. Electrical connections and fluid connections are always a problem.
Every connection or right angle in a fluid system adds to the resistance and increases the size of the pump you need. So when you see fluid primarily flowing in one direction through an electric battery system, there's less resistance there. Right here, Peter talks about the forced turbulence as the fluid flows through that. That is a really good idea to get the maximum amount of heat transfer into the fluid, but that forced turbulence also adds to the resistance of the system.
And drop your efficiency.
Yes, and they have 2 connections per module here, and it looks like how they point out straight up. That is 44 right angle connections versus a handful on a lower module pack. So Sandy, I stopped right here. I'm looking at these. What do you call this? Wire bond? Aluminum?
Yeah, this is a wire bonding application.
They don't look particularly...
They look fat is what they look. They look a little different than most everybody's. Most people are using a very, very thin wire because the current here is minuscule. The thing that's kind of important is how did they, first off, bond these things together? And then how are they doing the collection? So all these things come in series, and then you've got the collector bars. You can see them. Those look like they're the solid pieces of aluminum. And if you look, you can see how they cleverly tied these things all together so they don't short out. That's one of the big problems. So they weave a tortured path and connect everything, so you've got everything in series.
So if you look at the first collector plate, on this half of them, they're all connecting to the negative. So you can see negative, 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 negative. But when you go over here, it'll this half of the bar, it's all to the positive. So as the fingers stick out one way, you're collecting all the negatives from one set of 30 in parallel, and then you're going the other side of the bus bar is what he calls it, or we call it a collector plate, will connect to the positives, and then the next finger will pick up the opposite, and that's how it flows through. He does a really good job of explaining parallel and series, but we're more focused on the manufacturing quality, and I'm seeing all of these small little wire bonds at different angles, and some are bent a little, and I don't know if this is truly production intent, or if they will have a potted version when they're finally done, because the NVH and the noise, vibration, and harshness shakes really bad in an automobile, and these little wire bonds, if there's any difference in frequency between the cell and the pack itself, they'll break themselves loose. So we've gotten through the whole video. We're at 36 minutes at 36:47. I just think we need to take a little second to thank Lucid and Peter Rawlinson for even putting this out there. It was incredible. I mean, I don't want to say it was flattering to see this level of detail, because this is typically what we have been doing in the last 2 years, and other YouTube channels, diving into the minute technical details. And although we have been critical of the little things that we see that we don't like, still a very impressive car from an MPGE range perspective.
I don't know much about Peter, but I can tell you for sure that after watching this, he's my kind of guy. He is definitely a detail kind of person. I mean, somebody probably wrote a script, and like you say, there's a lot of razzle dazzle in this video. But still in all, somebody has to eventually. This is not a puppet. This is the CEO and president of a company, and I don't see that happening too much. I can't think of apart from Elon Musk, I can't think of any other president and CEO could pull this off.
All right, I think that's about it for us. It's actually more work for us to watch these videos and comment on it than creating our own videos of stuff we tear down. So if there's more of these that come out from Lucid, we may group them together or do another reaction video. So I hope you enjoyed what you saw today, and thank you to everybody who's subscribed in the past 2 months. We've seen a little bit of uptick since we, actually swallowed our pride and said, please help us out and subscribe. So thank you to everyone. And anything else, Sandy?
Thank you so much, and have a great weekend. Bye now.